Perks and pitfalls of passive house prefab. So I'm going to present two projects that I started in 2016 and they just wrapped up last year due to a number of hurdles through building departments, local appeal boards, and all sorts of things, but we're not going to talk about that because it's not really that interesting. And instead, we're going to look at two passive house projects that were both done with prefab envelopes, two different styles of prefab envelopes, two different builders, and two very different locations and conditions during the build. So the first is a multifamily passive house targeted residents in Toronto with a lot of items in it that passive house recommends you don't do. So wood burning fireplace, a gas stove, brick facade, and the caveat of all, not working with, we worked with a builder who did not believe in climate change at all. So hence trying to bring in a prefab builder. The second is a seasonal home just outside of Fort Erie. It's currently going through the PH certification process. It went up during the winter months of last year. It just wrapped up a couple months ago. I didn't get any pictures yet because I haven't been able to get down there to finalize it, but there's a moment frame because there's a big window wall in there, so a lot of steel. And there's security screens that double as solar control for the shading of the windows. So both projects present unique opportunities for collaboration between architect, prefabricator, and builder, and we'll touch upon those. So quick overview, 5 principles of the passive house kind of touchstone. You incorporate passive elements, the building envelope, losses and gains, balanced continuous ventilation with heat recovery, internal heat cooling, and humidity sources, and then zero carbon through renewables is kind of the 5th touchstone. We're going to focus on the envelope, looking at passive house, prefab. So this is our project in North York. It's a multi-generational household, solar ready, prefab building envelope, aging in place design, brick exterior, wood burning fireplace, and gas cooktop. So this is the team. Bellino Homes was the general contractor. They were hired by the client prior to myself being engaged, and they were family friends of the client, and so that's why they were brought on. Aldo is a 65-year-old Italian builder, does beautiful work in his wheelhouse, but his wheelhouse is not passive house. So from the outset, it was a challenge working with somebody that didn't believe in what we were doing and basically questioned every detail that I presented. So we brought in Pinwheel to build the shell and try to mitigate the possibility that we're not going to hit passive house with somebody that didn't even believe in the capillary break between the footing and the foundation wall. Zon Engineering did the engineering work, and Passive House 43, which is myself, did the architecture and the energy modeling and all the rest of that. So here are the plans, you know, pretty simple. This is the garage. So the garage is outside the passive house envelope. It's not good to include it, basic. So here's some elevations, and pretty basic stuff. This is the south facade, lots of windows to bring in that light and take care of the gains as much as possible. You'll see that there's quite a bit of overhang on that south facade. It's about 3.5 feet so that we can get solar control. There's a shading element that goes between the first and second story to provide solar control on the first story. So here's our initial PHPP design numbers. So, according to the design numbers, we're doing good. We're hitting the targets, and we're looking forward to building it and hopefully getting it certified, even with all those involvement. Here's Pinwheel's prefab model. So each prefabricator has a different system that they like to use, and I think this is CADWorks. And so they break it down and we'll lay out your panels and everything, and then You obviously go through a shop drawing review process to make sure that everything's lining up with the design. And then they'll start the construction once you sign off. So here's Hans's shop, and they're building Hans's pinwheel. Most of you would know him if you're passive house people, but if not, Hans's is amazing, and he saved this job. I can't say enough about how much extra he put into it. So here we just have the panels being constructed. This panel is a 9.5-inch I-joist on the vertical for the exterior insulation cavity, and then an interior service wall with a 2x4 stud. The air barrier goes on the exterior face of the service stud, then the sheathing, then the insulation cavity, and then another layer of sheathing and your exterior membrane. So we're going to look at some details. Here is the foundation. So we had to somewhat revise how the foundation work would go, given that we were working with a traditional, conventional builder who was reluctant to put exterior insulation on the foundation wall. We also have brick, so in order to get the brick to stand, you either end up building 2 foundation walls on the outside, or the solution that we came up with, myself and Hans at Pinwheel worked through it. We built an extra load-bearing wall on the interior of the foundation wall to pick up the load from the structural member of the prefab wall. And so it goes down, and then there's another kind of stub wall here, internal, that picks up the loads. So instead of 2 concrete foundation walls, we have a regular concrete foundation wall that the builder was familiar with. The brick sits right on it. And then on the inside, we have a wood-framed structural wall. And in between the two is 3 inches of extruded polystyrene. And after, I'm going to make a caveat, this was 2016. I hadn't heard Chris Magwood's presentation about embodied energy yet. So there's a bit of foam in this project, and there's foam in the other project. But moving forward, we don't spec foam anymore at PH43. Woo! Yeah. So it's really important as you're going through the modeling and everything. It's not just the PHPP modeling that you want to look at, but you also want to look at the thermal modeling and the hygronic modeling or hydrothermic modeling using WUFI, UWERT, or for the thermal modeling, use Therm. So it's not really showing it very clearly. Anyways, so this is the foundation. And again, I hadn't heard about foam glass yet. I probably would have used it there to break that thermal bridge. So we do have a little bit of a thermal bridge at the edge where the slab meets that kind of extra stub wall just in there. But we modeled it and found it didn't affect our ability to hit the passive house targets. So we just went forward with it. So here we have some pictures. You can see the insulation shoved in behind instead of block, they poured a wall. You can see also that they put the sill plate down without a protective membrane. In the first case, that was done by the general contractor. Hans came along, ripped it out, put the membrane down, and put a real sill plate. So that's going well. I'm already half a way through the time. Okay, so we'll go to the foundations. This is the internal air barrier on the basement. Again, the general contractor didn't want to install it, couldn't find anybody to install it, so I installed it with the owner. And my rates are, way higher than a laborer's rate, so I don't know how valuable that was to him. Anyways, here's the basement slab. That's for a post footing, all taped up. And here's Hans and his crew erecting the building. Another challenge with the prefab is we have a sunshade on the exterior. And Unfortunately, my structural engineer disappeared for 3 months, so I couldn't get this coordinated prior to Hans constructing the prefabricated envelope. So we had to retrofit the envelope he had already put up to get the steel anchors in to support the sunshade that'll be going up. So there you can see them after they've been installed. Poor Hans probably lost all of his hair when he ripped it out due to the frustrations of trying to put this in after the fact. So the point to take from that, coordinate early, because you don't know what's going to happen to one of your consultants at any point in time. So here you can see the kind of building as it's up and kind of weather tight now. And then here is, just going back to the detail at the transition here at the floor. So this was a major problem in coordination between the builder, the prefabricator, and missing it on the drawing where it states transition membrane to go from interior foundation air barrier to upper wall. That was never installed. So they moved ahead and the entire air barrier at the header of that first floor was missing. And of course, I was in Greece on my one vacation, so I got back and it wasn't in, and it was challenging to deal with. But we've remedied it since then, but we did the blower door test prior to that, and you'll see the results here. So the blower door test came in at 0.95, higher than Passive House. We couldn't hit it. But again, that's because we're missing the air barrier around the entire interior. So there's some photos. So we ended up with a 19. So if we look at return on investment, like Ben was talking about, that's really only $80 extra a year, So I don't think it's that bad. This is the second project, Bay Beach, prefab building envelope, solar ready, security screens, aging in place, building automation system for remote sensoring and control. This is the team, Evolve. Those guys are great. They worked with Lowry Building Company, who did the Pre-Fab Shell, and then kind of managed the on-site work. Then Zahn Engineering again, and PH43. So here we have the plans, the building. And so this was a bit of a different process. I worked with Lowry Building Construction to design the prefabricated building envelope, and then we built it so that 2 people could basically carry it by themselves and remove the need for a crane. So again, we're hitting our targets. We're doing pretty well here. We're at 13 for the heating, 9 for the cooling. These are the shop drawings. So the shop drawing review is really critical. You can see, my notes here saying, you're missing that steel beam. You got to cut your wall back a bit, etc. So here, it's a slab on grade project, and there is the slab work going in. So there's a rainy day, and then my second site visit was covered in snow. Here they are putting up the shell after they were able to chip the ice off the slab. There's Ben there walking through what is the kitchen area, but you wouldn't know that was inside because everywhere was snow. And here you can see they're starting to wrap this beam that's going out over this overhang with the air barrier. There's Ben and Eric, proud of their panels. So here we have an 6-inch EPS foam on sheathing and a 2x6 interior stud, and then we put the air barrier on that, and then we had a 2x3 furring chase for running services. There's the wall. And so here's the moment frame at the south window wall, where we have steel running through the building, and we have to support the windows on that because otherwise out here we're just supporting on foam. So we've got the steel inboard of the exterior insulation so that it's warm. Key to Passive House. There's one of the water table is 2 feet below grade here. So we have a screw pile to pick up those column loads. And then here we have a sunshade bracket. Sorry, not the sunshade, the security screen / sunshade bracket. So it's getting anchored in, so we have point thermal bridges here that there's not much we can do here unless we were to put a fiberglass or neoprene thing there, and cost prohibitive, so we just kind of took the hit on the point thermal bridge there. There are the brackets. Okay, I'm gonna slow down a bit. I raced through. Okay, so here we go. So the building's clad in standing seam and wood. That's, you're seeing the track here for the security screen. Inside, we've got the insulation going into the service cavity, or sorry, into the structural stud cavity. And then you can see the air barrier here that they've left hanging out to wrap up into the beam and tie it into the other section they have. Here we have a fully air barriered cathedral ceiling. That's looking out to the south wall. And this was the first run before drywall, and they hit a 0.54, which is awesome. So I imagine, we haven't tested it since the drywall's been in, but obviously that's going to drop it down. But amazing job by Evolve and Lowry Building to hit that target on the first run. Here's the almost finished product. We're missing the glass guard on the upper story there and the security screen, but everything's pretty done at this point. This was a great detail that the siding contractor actually came up with. I thought it was pretty nice. So it's the refrigerant loops for the air source heat pump. It's a nice clean little entrance that he created, which is awesome. That's the interior looking across out towards the lake. And then the kitchen. Our final results. So this we took a little bit of a hit because we're still hitting the targets. But I had not known at the time that we needed to have a certified ERV, because when I took the training and all that, there weren't really any certified components. And so that kind of came in, and you need to have a certified ERV in order to, well, you can use a non-certified one, but you take a penalty. So I had an ERV that was an 86.4, it was an Ultimate Air, it had been used before in passive house projects, but now it's not accepted as an 86.4% recovery. I had to knock it down to a 75. So that took a major, well, I thought we were gonna lose certification, but after kind of looking at it a little bit and modeling some of the thermal bridging and things, we managed to bring it back into the realm of certification, hopefully. Fingers crossed. So anyways, just something to know that if you're going to be speccing an ERV, make sure, check that it does have passive house certification, or you can get it to be recognized for what the value of it actually is working at. So here's a comparison. The heating demand in the first project is 19. In Bay Beach, 15. Cooling demand, 4 versus 9. That's due to even though that overhang is really well shaded, the west window is quite large and allows a lot of heat gain. Air tightness, 0.95 versus 0.54. The cost per square foot was about $285 a square foot for the first project, and then the second project was $355, and that has to do with premium finishes and equipment that they spec'd for the interiors. Brainpower spent a lot more on Ballyronan due to the contractor. Pitfalls of prefab. Without proper coordination, things can be missed and difficult to remedy on site. Coordinate early. Challenging at this point in Ontario to get fire-rated assemblies. Little room for error, foundation work is critical, shop drawing review is crucial. It can be challenging to work prefab deposits, cash flow into a traditional payment schedule format. So maybe talk a little bit after that because I don't have time to explain it. Quality control is higher, so that's a perk. The time frame to close in is much reduced, which is great. It is cost equivalent. The experience that I've had is it's cost equivalent to traditional building. Due to some of the coordination things, our construction schedule was about the same. Can provide method for traditional builders to get experience with pH, and not as weather dependent as traditional build, especially for pH where you're taping and things like that. So to have a conditioned space to do that in is great. Can you do MERB in prefab? Yes. So we're currently doing a 100-unit retirement home. We've incorporated prefabrication since the outset. And conclusions. Maybe I'll read those quickly. It will be very challenging to get through, but the builder has no pH understanding. If the builder has no pH understanding, it'll be almost impossible if they have no belief in what is being done. Prefab offers a way to bring quality control to the building envelope to ensure pH targets can be met. And as with any product, thoroughly vet the prefab assemblies through analysis. Analyze the wall system for not only thermal performance, but hygrothermic performance as well. There you go.